Hello everyone, this is my first video on the series of machine learning for beginners. This video is more towards introduction to machine learning. So as part of the polls that I made I think 3 weeks ago, most of you guys have gone for AI for beginners, for which this is the first video that I'm making. This channel DataTuber has now been shifted towards more in data-based technologies and all the data related skills that you can capture. It's going to help you a lot dealing with data intelligence and data engineering stuff. So 20% of you guys, they have gone for data engineering weekly series. I'm working on this. Soon I'll be making audio on weekly basis for latest data engineering updates, and probably that will help you out. Let's proceed with introduction to machine learning. So the agenda of video is starting with the exact definition of machine learning, some examples to understand how machine learning is different from the instruction based programming, types of machine learning, which are supervised, unsupervised, and reinforcement learning, and a quick glance on what all things that we have gone through in this video. Let's come up to the definition of machine learning. So you can define machine learning through many ways, but there are two main definitions that we talk about whenever we discuss machine learning as a definition. First definition is given by Arthur Samuel in 1959. That's the very first introduction of machine learning. And what he says is that it is a field of study that gives computers the ability to learn without being explicitly programmed. So these two important terms that I've underlined define this in a way which is separate from just giving instructions to the computers in form of program. So in this, the computer is just learning. It's not getting programmed. It's not receiving any set of instructions. It's just learning. It is just an ability to learn. How, what is never been mentioned in this definition. It's just an idea, just a thought that the computer can learn without being explicitly programmed, just working on itself to solve a given problem. So a better refinement of this definition comes in 1998. What Tom Mitchell says in 1998 is that a machine learning is a computer program that is going to learn, right? The learning that is presented in the previous definition in 1959. Now, what he says is that it's going to learn from an experience E, right? And with respect to some task T, right? And there's going to be some performance measure P. So there's going to be a task which is going to get performed based on an experience E, and there is going to be a performance measure to that task. How much the task is credible, the credibility performance measure, which is defined as P. We'll understand in an example on what these definitions really mean. So as an example of machine learning, we're going to understand the very latest and very common example that we are recently going through is LLM, right? LLM is a machine learning model. So large language models, right, like ChatGPT, Gemini that we're using on daily basis, they are trained on a massive data set of natural language, that is human-like text languages, and it can answer your questions in a, whatever you ask, it's going to understand, right? So answering your questions or giving you that specific set of information that you're demanding, actually information about anything, right? You can text actually anything, you can query anything, right? So this query, irrespective of any set of instructions, can go to this LLM, right? And as a output, it can give you an answer to that query, whatever this model feels like. The answer may or may not be very specific, but this answer is never governed by a set of instructions. It's not explicitly programmed. And this is how the definition that we did, right, in 1959, it links to. So it's a machine learning model because it's not explicitly programmed and it's generating by understanding whatever your query is. And one more example that we can think of here is fraud detection system. A fraud detection system, and let's try to link this example with the second definition, the latest definition in 1998 that Tom Mitchell gave. So, how can we link this example to Tom Mitchell's definition? We're going to divide all his terms to try to understand what is this model actually doing. So, a fraud detection model, right? It's going to learn from an experience E. So, what is an experience E? It's having a lot of data, right, to feed in, to understand what kind of transactions are a normal one and how a normal transaction can be differentiated from a fraudulent transaction. So a lot of data having a legitimate and fraudulent transactions. And then there is going to be a task. Program itself is a task T, which is classifying it. There's going to be a performance measure P, which is percentage to tell us that what amount of transactions are correctly identified and classified into a fraud transaction or a legitimate transaction. And this is the three main factors that the second definition tells us in addition to the first definition of machine learning. Then we'll go to the next topic of types of machine learning algorithms. So we have supervised learning algorithms, unsupervised learning algorithms, and reinforcement learning algorithms. Supervised learning algorithms are those algorithms which are fed with labeled data, or we can say it is having right answers based on which it learns. Unsupervised learning models are those models which do not require any labeling for learning. It's kind of a clustered data which identifies in which category a data falls into. And there's a reinforcement learning algorithm, which is a third type. Reinforcement learning algorithm works on state and reward. So this algorithm, based on the maximum reward, it takes action to go from one state to another. So it's the reinforcement learning. It's basically getting constant feedback, constant reward on each and every trial that it makes. So based on trial and error, it's going to get an estimate on the maximum rewards for a particular action that it takes, and based on that it's going to learn how to act in a certain environment and reach the maximum reward. That's going to be its aim. Let's come to supervised learning. Let's talk about it in a more detailed manner. Supervised learning, as said, is a labeled learning. It's having a labeled data set L. This data set looks like a vector where we are having x and y, right? So what are x and y? Let's try to understand now. So x and y here can be said as x as features of the data. Let's say f is the feature of the data, and y is the value that the model needs to predict, right? The value v. Okay, so let's take an example of a model which is predicting the price of the car P, right, given the engine size of car as E. So E is the engine size, P is the price, right? So the more the engine size, the more should be the price. So we are labeling it as X. Mostly the data looks like this only. Maybe some cases where engine is big and price may be a little low, but mostly we can have a direct relationship between price and the size of the engine. So this is the data which is fed into the model. This data acts as an input to the model, which is actually trying to learn the pattern of this. If you can see, right, this create a line in between like this, right? This line is approximately predicting to a very greater extent the price of the car based on a given engine size. So let's say now we are giving an input circle, right? This is a new input. So the model gets itself trained on this data set it's able to define a function which is making a line on this graph, right? We'll try to understand more on what it is and how it is actually making this line. But it is trying to get itself fit to the maximum data points that we are trying to capture here. And this means that tomorrow, if we get a circle as a new input, if we, let's say we have a engine size which is circle, right, which is actually circled, and based on this value, right, I can actually predict that here somewhat here is going to be the match, here is going to be the line, and based on this we are able to identify that this point y dash is going to be the price of a car given on the engine size of a car, right? So this is how the supervised learning works, and this is an example of a single variate regression that I am talking about here. So regression problem is one problem which is an example of a supervised learning. We just discussed about a single variate linear regression. So multivariate linear regression can be whenever you try to add another variable into that one single data set, which is again having a linear dependency on. That's going to be an addition of a third dimension. So the data maybe looks like x1, x2, and y. This is just an example of one multivariate regression. So just like we talk about, we have a y, we have a x1 here, right, and there will be another third dimension which is x2, right? So these are the axes, these are the three axes, and consider this as a 3D axis scenario where we may have this line, right, and we may have these as the points. Maybe this is the point, this is the point, this is another point. So it's kind of difficult to relate it, but consider it as a 3D scenario. It's a 3D graph. And what is logistic regression? Where we are trying to classify the data in 0 or 1. So the question is, why do we need it? Let's consider an example. Okay, we have these set of features where let's consider a problem. We are trying to classify a mail as a spam S or a no spam N. Okay, so based on the given features, we are trying to identify whether the mail is a spam or a no spam. So spam mail can act as a 1 here, and a no spam can act as a 0. So these are those kind of cases where we have a 0 or a 1 scenario, right, where we are doing a classification, right, binary classification right now that I'm talking about. So let's say that 0 means it's a no spam. So we are saying n, another n, another n, right? Then there are like spams, which is an s, which is an s, plus again s, s, and there is an s, right? So if you try to fit a linear regression model in here, it is somewhat like this, right, which is not correct, not kind of correct, right? It's going through two data points, but not exactly the trend, right? So maybe any feature which goes beyond this point will always be classified somewhere as a spam only, right, which is not correct, right? So to do that, we need some kind of curvature, some kind of a Z shape, right? So if I make another set of no spams and another set of spams, so we need this kind of a shape, right? So this kind of shape actually fits better than the previous one, quite perfectly, and it's able to identify on which point we say that a mail is a spam or a no spam. So to cover up this use case, we use the concept of logistic regression model, which is another kind of a regression model only, but it is having a different formula. So we will cover this up in another video. uh, Probably in the next couple of videos we'll be talking more about the exact calculation, but this is somewhat is the formula of a logistic regression. And if you try to plot a graph for this formula, it will be a sigmoid graph only. So this is known as sigmoid graphs, and this function is called sigmoid function. So the sigmoid function, actually here this value can be a little confusing. It's not y, it's x. Actually it's a given whole formula, right? So where x can be written as a simple regressive function, like where we have x1 and x2. We can take a simple regressive function where we have a beta, which are weights. We'll discuss about these weights uh, more in next video, where we will be covering in deep what is regression. These are coefficient for their respective weights, beta 1, beta 2, and intercept. I'll cover up this concept in the next video. We will be discussing in deep about what is gradient descent, what is a loss function, and what are these beta weights, and what is this intercept value. So we can say x as this, and the whole formula can be said as a y dash, because it is the value that the model returns. So the next thing that we're going to talk about is unsupervised learning. Unsupervised learning or unsupervised learning algorithms are those algorithms which take unlabeled data. That means there is no labeling to that particular data, or there are no right answers as such, and the data set will look like let's say x1 a single feature, x2 will be the second feature, and so on, n features. So we will have xn. The data will look like this vector. And if you try to plot it on a graph, right? So let's say for n equals to 2, right? If you put n equals to 2, it will look like this. So just for ease, let's plot it on 2 features only, and this dimension is 1, this dimension is 2. These are the data points. So data point 1, data point 2, you can consider these as rows. Plot it more, let's say there are these 10 data points. So we have created 10 data points here, right? This is how it looks like. So unsupervised learning algorithm will look for clusters and will actually identify a cluster based on the given number of clusters as an input. Maybe a number of clusters, maybe input can be number of clusters, input can be a distance of points from a center cluster or a radius. Based on the input, the model will train itself on the present data and identify the clusters. So let's say for this case the input is 2. So when I talk about input, right, I am trying to say that we are adding or we are providing something from outside, right? So this thing which is being provided, some just provided from outside, means which is not getting trained within the algorithm, is called as hyperparameter. Hyper, and just for short form I'm writing P for parameter. This hyperparameter for this case right now that we are taking, it is, let's say, 2, right? So by 2 it means that we are trying to identify only 2 such groups or 2 such clusters within the data points, and based on this factor, model will train itself. The model will try to look for 2 clusters within the given data points within these 10 entries, and it will actually find this and this as the 2 most effective clusters, right? These are the 2 most effective clusters which are clearly visible, right? And let's say if you set this parameter as 3, right, then what will happen? Well, in that case, let's erase it. It will try to get the three most feasible clusters, right? Maybe this is one, maybe this is one another, right? And maybe this is one more. So the most feasible number of clusters it will try to get to have a most clearer separation or most clearest separation possible. Let's go to the type. So as I told you, hyperparameter can be of different kinds. It was one example of unsupervised learning. By K means, what we mean is that K acts as a hyperparameter where K is nothing but the number of clusters. So in our previous example, 2 and 3 here may act as a k-mean hyperparameter, or what we say K. How it works is that it tries to find a number of clusters based on the data points near to a given mean of cluster. So let's say this is the mean point here, right? And uh, this is the distance from this point to this point. This is the distance from this point to this point. This is the distance. Now if I take distance between this point and this point, right, this will be greater than this point and this point. So based on that, what will it identify is it will actually mark this as a part of a second cluster, right? So what will it do is it will, so based on the distances between two clusters mean points, it will associate or allocate each data point into one given cluster. And so it is an iterative process. Every time you start assigning k data points, right, as the mean, and then so step 1 is you assign k data points, let's say 1, 2 and 3 data points as mean points, and you try to get all the distances right from that point, right? And based on the lowest number of distances that each point will have with all other points, you create a cluster, maybe something like this, or like this. And in the next iteration, what you do is you always take mean of all the distances and you assign a new mean, and then you continue that way. So this is how the k-means work. Continues till the time you always get a particular mean point which is having the least differences for endpoints, and you assign endpoints to a cluster. Next is dbScan. dbScan is density based spatial clustering of application with noise. What that means is instead of taking n clusters as input, it takes two hyperparameters. One is the radius, the other is m. That is, so all the points should lie within a radius r and with a minimum points m. So m should be the minimum number of points for assigning a set of data points as a single cluster, and they should also lie within the radius r. Anomaly detection is the machine learning algorithm which actually detects any uncertain or outliered point. So it always detects a certain or outlier point based on the given data set, and this machine learning model is trained on a particular data set that has a kind of nature where everything in normal lies in a certain threshold, and if it goes out of that threshold value, it is considered as an outlier. So that's an outlier identification. So how you do it? It's like, let's say an example that we have a CPU usage of a server, right? And also we have a RAM here, right? So there are, and we have n processes for which there is a state recording going on live. So one process lies here, one process use this much CPU and this much RAM, one here, one here, and one here, one here, and then certainly there's a process which is using high RAM, right? There may be a process which is using a high RAM and a high CPU. There is a process which may be using a very low CPU and a very high RAM, and maybe there is a process which is using very high CPU, usage, right? And maybe a reasonably low RAM. So these will be identified by the machine learning algorithm, right? So it will create a cluster here and it will identify these 3 points as a outlier, because these are outliered cases. These are exceptional cases. So let's say this point, right? So if you really get this point while monitoring your processes, you generally have a case where a process is using excessive RAM. That means it maybe there is an object which is having a network connection to database which is not closed yet, right? So that object is maybe having a very big result set, and it's not, even though it's not using your higher CPU, but it's having a result set, so it is storing that thing into the RAM and it's not closed yet. Maybe that's the case. And maybe here in this case, right, where the data point is using a lot of CPU resources and a very less of RAM, that means maybe there is a malware or a ransomware running up which is encrypting all your files. Maybe that's a dangerous point. So identifying it in a real time manner is somewhat which is very good usage here in anomaly detection, and uh, this helps us when monitoring processes on a server. So the last type of machine learning algorithm, or last type of algorithms, is reinforcement learning algorithms. Reinforcement learning algorithms are based on constant feedback during the learning that is provided in form of rewards. There is a chain of states like S1, then there is state S2, then there is the state S3, and say to Sn, right? These chain of states are each linked to a previous state, and for each state you have a reward R, right? We have a reward R1 here, R2 here, and so on till Rn. And uh, for going from state 1 to state 2, you have to perform action. So this can be said as A1, and from state to state 3 can be say A2, and thus for 3 to, let's say, 3 and ahead, it will be A3, and then the last action can be AN, that will uh, make it to reach our state Sn with the reward Rn. So uh, this reward actually acts as a feedback, right, to the agent who is performing these actions, and this agent can be nothing but a machine learning model trying to learn the best set of states. So basically it's learning the best actions to perform the best states to reach in a particular situation, right? So here you can see like there is an agent which is performing an action in a particular environment, right? And after performing an action, it shifts its state, and based on that it is feedback with a reward. So you can see there is a feedback going up as a reinforcement to whatever action that the agent has performed, and based on these rewards and based on these trial and error that the agent do, the model is able to understand what are the correct set of actions that it should take in a particular given environment to get the maximum reward. So we make the algorithm learn by providing constant reward feedback. We all also call it as Q values. We will be discussing more on further videos when we will be going into a deep insight of how generally we use neural networks in reinforcement learning, and how we generally train these models to get the best set of actions. So basically we divide these into two types. One is model free, SARSA, and Q-learning. SARSA is a non-policy reinforcement learning model free algorithm, whereas Q-learning is off policy. We'll be discussing on the policies. Another is model based, And what happens is, based on a given set of rules in an environment, the model based reinforcement learning works. So model based can be all the set having all the set of rules based on maybe a probabilistic terms, or maybe a your deterministic terms. So we will go more into reinforcement learning, but for now we need to understand is that this is something which is training the model based on a reward or a feedback that is coming after an agent takes an action in a particular environment. Let's go to the quick pointers on what we take from this lecture. General definition of machine learning is that it empowers the computers to learn from data, and we also talked about the basic experience that it learns from the data, which we marked as E, and the task T, which the machine learns after taking the experience E, parameter uh, P, which is going to evaluate the learning capability of a task based on some kind of a percentage or some kind of a metric. A large language model, we uh, talked about our LLM, how the LLM is not actually a deterministic set of instructions, or not actually a programmable thing, but moreover something that has the capability to understand natural language or human text, because it has been trained on a certain set of examples, certain set of experiences being provided to it. And we also talked about supervised and reinforcement learning, where we provided that we have the right answers given in the supervised. We don't have any labels in unsupervised. We generally expect model to differentiate and categorize the data, whereas in reinforcement we focus on making decisions, and based on a constant feedback we try to modulate the set of steps to reach a certain goal or a target. And here we have a quick glance on how everything looks like. We talked about classification problem and a regression problem. In regression problem we saw single and multivariate regression that will be covering in the next couple of videos after this, more into the loss functions, more into the gradient descent, and we'll try to understand using logistic regression how the classification is done. And in clustering we'll go towards k-means and db-scan, uh, and we'll try to implement both of these two by scratch, and also try to implement regression and classification, specifically logistic regression, by scratch in Python using NumPy. And then we have reinforcement learning, in which in a particular environment agent goes through states based on constant feedback from the environment, and the agent perform best possible actions to get the maximum feedback. Here we end our lecture. Thank you everyone for watching my video. I hope you like it. I hope you find it informative. If you find it informative, I'll request you to please share this video, because I'm going to bring more and more into this series of AI for beginners. I'm trying to make it in a manner that each and every one of you guys who is familiar with basic mathematics and basic programming skills can actually understand what's going on behind the model. So I hope you guys subscribe to my channel for more upcoming videos on the same topic, and please share it. That will give me a positive feedback again. And by the word feedback, I'll also recommend you guys to please comment any questions if you have within this lecture, uh, and also tell me how do you like this video. Do tell me a recommendation how the next videos should be, what all improvements can be done over it. I really recommend you to write those comments. Those help me a lot in improvising myself in the upcoming videos. So thanks for watching. Please like if you like this video, and share and subscribe. Thanks.